Hi everyone, this is Dr. Anna, and today I'm gonna do the final review for you. I have opened all the chapters we're gonna have the final on, starting with the mass movement. And this here shows you the slideshow mass movement. I'm gonna make it larger. And of course, you have to know what is the controlling factors. You know that the gravity is the most important, but water is very important also. Um, this is the figure right here. If I ask you, this is what you have to draw. And remember, the gravity has two components. One is which is perpendicular to the slope, and the other one is which is parallel to the slope. And when it's deciding if there is a mass movement or not, then the downslope component is what's really important. The perpendicular component is actually adding to the friction and the cohesion, which is the force holding it up. You do know that the slope composition is extremely important. You have to know that solid rocks are much better. However, if they have weakness on the slope, you know, any kind of weakness like tectonic deformation, frost wedging, layers of sedimentary rocks or soluble rocks like limestone in a karst area, or foliated metamorphic rocks, it makes it worse. And also remember that if you have a weakness plane which is parallel with the slope, it makes it worse. If you have unconsolidated material, you got to know about the angle of repose, and that is different in different type of sedimentary rocks. Remember, we talked about it. You understand that the vegetation is very important. The deeper the root system, the more stable the slope becomes. How do we set the mass movement? You know the natural triggers. It's kind of important to know them. And then you know the man-made triggers. Just kind of be able to list them. And then the types. Of course, the types of mass movement is very important. You should know them. I might ask this. And then you have to tell me about the creep, the solifluction. Remember, the solifluction only happens in polar regions. And of course, the rapid mass movement. So you should know all of them. You should know the difference between rock slide and the slump. You know, remember the slump has the curved slip place, where the rock slide has the straight slip plane. Then of course the earth flow, this is the dry one, less dangerous, and then the mud flow, which is very dangerous, and the worst is the debris flow when it's with the rocks and everything. How do we predict mass movement? That's pretty important. And what do you look for? And how can you do stabilization? So that's about the mass movement. These are just pictures, so it's not that important. So we finished with the mass movement. The next chapter is the running water. Remember, the running water chapter is pretty important. You should know the different sources. Of course, you don't have to go into this little detail right here. You don't have to know the freshwater lakes, or just know that the oceans is 97.2, glaciers is 2.1, and the groundwater is 0.6. The hydrologic cycle, you should be able to draw it actually, and make sure that you know these words. And these are the fluvial systems. Well, how do we use the running water? What is unconfined, confined flow? You should know the unconfined. What are rivers? It's important. Now, the longitudinal profile, and I want you to be able to draw this. Like, you just draw the river from the mountain to the ocean, and what is the difference with the channel shape in the mountains, which is the headwater part, versus the ocean, which is the mouth part. Remember, headwater is V-shape, the river occupies the bottom, and the mouth part is wide, big floodplains, and the ocean, the river itself is relatively wide and shallow. So it's very important that you know this difference. What is laminar and turbulent? Remember, if I didn't ask any of these, you can always use it for extra credit. Of course, you got to know the factors which affecting stream erosion and deposition. velocity and discharge, you have to know which one is what, and why the highest velocity is not on the surface but in the middle, and what is the difference when the stream is straight versus when it's meandering. How do we calculate the velocity, and what does it depend? The gradient and the channel shape. You got to know the gradient. This is important. It's right here. The difference in elevation versus the distance. Remember, if you calculate it in percentage, then you got to put the units into the same. So the same unit for the elevation difference and the same unit for the distance. It should be in feet per feet or miles per mile. The main thing is that to calculate it in percentage, then you have to have the same units. Okay, the longitudinal profile again, remember at the headwater part the gradient is steep, at the mouth part it's gentle, and this is just about the channel shape and roughness. You know, like whenever it's rough, it's slow down with the speed. When it's smooth, then it's faster. The discharge, got to know how to calculate the discharge. It's right here. And it's important to know in every minute, in every stream, what is the discharge, because remember, because of the flash floods and the flooding. Stream erosion, you got to know these three things. The hydraulic action, solution, abrasion. And how the sediment is being carried, the bed load, suspended and dissolved load. These are important things. What is competence and capacity? You can expect a true, false, or multiple choice question for those. The different floodings, know something about what is the difference between the flash floods or normal floods, and why do we have more and more flash floods? It's important. Types of stream, I probably will ask that, so you have to know the types of streams, or alluvial fan, braided stream, meandering stream, delta. If I were you, I would be able to sketch them all. So remember the alluvial fan, I cannot draw with this pen here, but the alluvial fan is when you have the fan shape, and it's coming from the mountains, and it's very fast and carries a lot of sediments, and when it gets down to the flat area, it just spreads it out. So the stream itself splits into smaller channels. The braided stream is right below the alluvial fan, and you have very, very fast moving, lots of sediment, and it puts down into low islands. So the braided stream is a lot of split channels still with a lot of sediment. Meandering stream is when it's absolutely flat, remember, so you can draw it. And remember, it has the oxbow lake, the cut bank, the point bar and all that. And the delta, similarly to alluvial fan, is when it enters the ocean, slows down and splits into a bunch of channels with a lot of deposit in between. So this is really important. So you will know that. And then the stream as a system, you got to know what is a drainage basin, what is the drainage divide. As an example, the continental divide, and you got to know what is base level, what is graded stream versus ungraded stream. That's very important. And then the drainage patterns, I might ask that too. So remember, the types of river is the alluvial fan, braided stream, meandering stream, and delta. The drainage patterns is the dendritic, rectangular, radial, and trellis. Those are the four you got to know. And then what is the Davis cycle? That is when we're talking about youth, mature, and old age, and what happens during age. It's kind of important to know. I might ask that too. And what is the rejuvenation? That is when an old age stage stream gets uplifted, and then, you know, it has to cut down to the base level again. So these are the things you got to know on this slideshow. So let's move to the groundwater. And the groundwater is pretty important chapter. You got to understand where is the water coming from, of course from the rain and the snow. Got to know what is porosity, what is primary, secondary porosity. It's important to know. And so this slide is pretty important to know, like primary, which forms when the sediment settles down. Secondary is after the rock becomes rock. It's like faulting and dissolution. And you got to know what is permeability, know the difference between porosity and permeability. This is really important. And then you want to know that the porosity and permeability, how does it relate to each other. This slide kind of shows you that just because the porosity high doesn't mean that it has really good permeability. One really good thing is the clay. See, it has really high porosity, very, very poor permeability, and you should know why. What is the aquifer, aquiclude, aquitar? These are important things. What is an aquifer? It's kind of good to know. And a couple of examples like the Florida aquifer and so on. Water table, I'm going to ask this. This is going to be on the final, so you got to know this. And if you draw this one, you're good to go. Remember the unsaturated zone when you have water and air, and the saturated when it's all filled with water. What is birch water table? You should know that's when you have a aquiclude above the main water table, and it makes a temporary water table right there, which you call birch water table. So the shape of the groundwater table, you got to know that's equal with the shape of the surface usually, and you got to know what is the recharge, discharge, of course, and then the Darcy law, which is right here. That's the hydraulic gradient. So you have, if I asked you how do you calculate the hydraulic gradient, you got to know it's right here. The hydraulic gradient, or the speed of the groundwater, is K times H over L, where H is the elevation difference between two wells, and the L is the course, the distance between the two wells, and the H basically is the elevation difference between, we also call it hydraulic head. Okay, so the hydraulic head is going to tell you how much pressure is in the water to move it down faster or slower. The steeper the slope, remember, the faster the water movement. You have to know the affluent and influent streams. It's not that difficult. And then the natural discharges is just a spring, different types of springs, and the artificial discharge, which is the water valve. Here you got to know the cone of depression, and I guess you will know it's not that hard. And then of course you have to be able to draw the artesian systems and know what is important for the aquifer has to be confined. Remember, clay and the aquifer is in between, and it has to be tilted to build up the pressure, and then there has to be precipitation so the water actually will flow by itself. Remember, with the this is the elevation the water is going to rise to, and that is the projected water table. This is just an example, so I won't ask this. The artificial artesian system is the water tower, remember? Then know a little bit about the hot springs and geysers. How do they work and why do they import geothermal energy? That is because of the hot springs, underneath. And yeah, of course you have to know the cause. How did the cave form? What kind of important things comes with the karst? The limestone or dolomite with acid rain or rain, just regular rainwater will dissolve the limestone. And the features, remember the cave, the disappearing stream, natural bridges or tunnels, sinkholes, springs, so on. And what kind of dangers, like we have sinkhole collapses, and these are the karst. Know a little bit about the formations in the cave. We went through at Dixie Cavern all these. And then the problems, of course. And when I asked you the problems with groundwater, you got to know all this for, and which one means what. This is really important, okay? And this is just all about that. So they finish with the groundwater. The next chapter is the structure. With the structure, you should know the different deformations you know, remember we have the three kind of stress, the compressional, tensional, and shear. You know which one is what, and what happens, like what kind of plate boundary will you have. That this covers it up just a little bit. I think, no, I cannot move it, so that's good. You should know that the strain can be elastic or the plastic. Plastic is when it's hot, remember, when it's high temperature, and then it's folding. We also call it ductile. Or it can be brittle. Remember, that happens when it's cold, and then you got fracture. Remember, every single earthquake is a fracture. So earthquakes happen in areas where it's relatively cold. So it's kind of important. What is strike and dip, you should know. And then you have to know the different kind of folds. The monocline, which is just a very simple, what is anticline, and that just means that you have the same kind of pressure on from both sides. It could be sometimes not the same kind, then you have asymmetrical, or if it's the same, symmetrical anticlines. And then you got the syncline, which is the downarching fold, so that's about the folds. And then you got the brittle deformation, which could be the joints or the faults. Focus on the faults. Remember, we have normal, we have reverse, and with the normal, you have when they are facing each other, that's a Graben fault right here. And then you got the reverse fault. And we talked about the so-called thrust fault. Thrust fault is when the angle of the fault is much smaller. It's less than 45 degrees. That's the thrust fault. And it also happens on convergent plate boundaries. And then the strike-slip faults. Remember, we have right and left lateral strike-slip faults. And that's about the fault. So you know the different types of folds and the different types of faults. That's kind of important. And these are just examples. And how do we tell? So that's about the structure. This is the earthquake. With the earthquakes, we know that every single earthquake is a fault line. Should know the elastic rebound theory, which was made by Reed. And then the important points like the focus, epicenter, and how the waves are going, the seismic waves from the focus versus the epicenter. It's kind of important. From the focus, they're going on a sphere, and from the epicenter, they're going on circles, like when you drop a rock in the water. And so know how the body waves are going. The body waves are the P and the S waves, remember. What is their speed? Why do we have the range? It depends on the density of the rocks and so on. And the S wave is going slower because it's going perpendicular to the propagation. So this here is the P wave and the S wave. And then the surface waves, those are the ones which are traveling on the surface. They're slow, so it takes a long time for it to move through. This is not that important, but the only important thing about this that the P waves go through liquid, but the S waves will not go through liquid. So this is how we know that the outer core is liquid. Know the seismograph and how does it build up, that you have the moving part and the non-moving part, and the moving part is what records the seismogram. A little bit about the difference between the P and S wave, and what, if you did the earthquake exercise, you are really up on this, so you know exactly how to tell from 3 seismic stations what is the epicenter right there. So hopefully you all did that, so you exactly understand what about the earthquake. The depth of the earthquake, remember, it has to be relatively cold to have a fault line, so therefore most of the earthquakes are shallow. See, 85% of them are shallow. Very, very few intermediate, even less deep focus earthquakes, because it has to be cold and rigid to be faulted. So that's why most of them are shallow. And they actually delineate, means that they draw the plate tectonic boundaries, because most of the earthquake happens along the plate boundaries. The intensity scale and the Mercalli or intensity scale and the Richter scale. Why is the Mercalli scale is subjective? It's important to know. And then the Richter scale, and how do we measure it exactly? That it's the amplitude of the S waves, and that's how they define the magnitude, and it relates to how much energy got released during the earthquake. What are the areas in the US where you get a lot of earthquakes? It's mostly related to plate tectonics, and you know the one in along the Mississippi used to be a divergent, but then it failed to become one. We don't really exactly know why we had this big earthquake here at Charleston, South Carolina. So it's not, we cannot say 100% every earthquake relates to plate boundary, but most of them do. And this shows you all the earthquakes, which clearly shows that they actually do delineate the plate boundaries. So we know the plate boundaries because of the locations of the earthquakes. You got to know the effects. So you got to know ground motion, fire, the landslides. You got to know the aftershocks, tsunami, what is tsunami and what happens. Liquefaction, important. So most likely I will ask you the effects of earthquakes, and then you have to be able to list them all and say one or two words about it. So this is just about the prediction. You know, it's impossible, but there is a couple of slides here about it, and the earthquakes in Virginia, just a little bit about that. The next one is the last chapter, which is the shoreline right here. So here I would like you to know what is the waves and all the parts of the waves, you know, the height, the crest, the trough, the wavelength, and the wave period. So these are important. What is the factors which influencing the height, the length, and the period? And then the movement of the wave, like you should know that the water itself is not moving, it's just the waveform which is moving. And what happens when it gets to the shallow water? So you of course have to know the wave base, the surf zone, the backwash. You should know what is wave refraction and the coastal currents, the longshore current. It's very important that you know the longshore current. Of course, the rip current, that is one of the most important. Like, I really wanted you to know that, so it's important. The tides, of course, you have to know the tides and the causes, the gravitational pull, and the centrifugal force from the rotation of the Earth-Moon system, of course. And you got to know the different tides, the semi-diurnal, diurnal, and mixed tidal pattern, so you got to know that. The spring tide, of course, it's very important. The tidal interval, tidal range before, and then the spring tide, nip tide, the ebb tide, of course, and the slack water. That's important. That's the time in between. You should know the process which shapes the coast and the types of landforms, like sea caves, sea arch, sea stack. This is important. And then I will not really ask the boundaries of the beach. However, you got to know the sediment forms which can form from the longshore current, which is the spit, the baymouth bar, and the tombolo. Okay, and then you got to know the human-induced depositions, such as the breakwater, the jetties, no, the groins. Sorry, the breakwater, groins, and the jetties. I said it first, so that's cool. And that, what is the beach nourishment? Sometimes it's a bad thing. So, type of coasts, you should know the primary and secondary coast. What does each mean? That's important. And what does it mean in terms of the sea level? And so that's it. I hope that you will be able to study well and get ready for your finals. Don't forget that it is going to be 25% of your grade. So study. See ya.